Can you guys hear me, or can you guys hear Trent?
I can hear you guys.
I can't hear him.
Trent, I think we lost you.
Yep. Okay, I can't hear him anymore.
Oh.
Yeah.
Oh, hold on.
Can you hear me now?
There you are.
Yes.
Okay.
I'm still echoing. Must be my connection.
Okay, so talk to the PA, and that's when we lost sound.
I didn't talk to the TA, but I did talk to an online tutor,
Okay.
and he was actually very helpful. He gave me the formula to find the margin of error for a pair of data, or the difference of the pair.
Oh, good.
Whenever he gave it to me, he actually let me see, where did I put it? It was upper interval minus lower interval divided by 2. And then he also gave me a way to figure it out with if you don't know the confidence interval, but he said that's the actual equation. He said there's all kinds of ways to figure it out. Yours being one of them, Laura.
Oh, good.
Well, you'll have. Do you have the keys to Kelvin's car?
No, I don't. He would have them.
Well, his car is here because no one can find them.
What? Maybe I didn't. I'll have to look them later. Was that a dog? It sounded like a dog whining.
All right.
Okay, are we?
Do you want to go over anything from the preparation assignment, or do we want to just go straight to the quiz?
I think just go straight to the quiz.
Sounds good.
What you eating?
Quesadilla.
Ah,
Yum. Mexican is a good idea. Maybe that's what I'll make for dinner.
Mm-hmm. Yep.
I got some queso fresco today. Oh, but I forgot to approve it.
You what? What?
I got everything from Mexican food except tortillas. Yeah.
All right, do distribution applets. First one. Okay, question 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all the blank. A simple random sample drawn from each population. And then I think the X-bar is normally distributed for each group.
That'd be my guess. Interesting. The sample size doesn't have to be the same size.
Because they're independent.
Yeah. They don't have to be paired. For hypothesis. Let's compare it to.
Who wants to take 4?
I guess I'll read it. The test statistic for a hypothesis test comparing two means with an independent sample is
My guess would T-score.
Yeah, I was thinking T-score because it's kind of what we've been dealing with mostly.
Yep.
And the fact that we're using the T-applet.
Yeah.
Intent.
I would say it's question 5. Two samples are independent if knowing which subjects will be in group 1 tells you nothing about which subject will be in group 2.
Yep.
I think so too. All right. B1. All right.
Okay, for the next 6 questions, use the data file, dentist office bills. This data represents a simple random sample of dental bills at a dentist office in Idaho Falls and a dentist office in Rexburg. Let mu1 be the mean bill at the Idaho Falls office. And let mu2 be the mean bill at the Rexburg office. Perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office, which means we have the null hypothesis of H sub O colon mu sub 1 equals mu sub 2. So the null hypothesis is the mu of the Idaho office equals the mu of the Rexburg office. And alternative hypothesis, now why they didn't change it to H sub A, I don't know. H sub A colon mu sub 1 is less than mu sub 2. Use the level of significance of alpha equals 0.10.
Okay, so how do we calculate the degrees of freedom?
Well, all we have to do is open up the quantitative inference procedures page, and we go to the third tab, to sample t-test, because this is not paired, and then we go start cutting and pasting our stuff in. So mu1 is Idaho. False.
Here we go. Where? Oh,
Okay, so we need to make sure we change the confidence level to 90%. So 0.90. And type of test is less than. And my degrees of freedom are 37.996. Anybody else?
Both dentist office have the same amount of values.
Mm-hmm.
So wouldn't it just be 20, the number of the...
Yes.
if it's the same?
yeah.
Oh wait, no, it would be 19. It'd be 1 minus.
No. Degrees of, no, it gives you the degrees of freedom down in the bottom under 2 sample t-test. First you have a T and then DF for degrees of freedom. Degrees of freedom in this 2 sample t-test where they're independent is completely different from what it's going to say.
Okay.
So it's 37.996 on my page. Anybody else get the same thing?
I got the same thing.
Okay. Let me just input the data.
And then my sample standard deviation for Rexburg, which is variable 2, is 206.637. Is that what everybody else got?
Yep.
Back to the degrees of freedom. Did you get 37.996 or 33.996?
37.996.
Okay, I wrote it down and got it. I thought I had 30. So yeah, got the same thing.
Anybody else want to take 8?
I'll take it. What is this? The test statistics. So that's the T, right?
That's the
Nine.
T. Yep.
Minus 0.4384. Did you get minus 2, Laura?
Yeah, minus 0.434. I'm sorry, I nodded instead of saying something. And it looks like the p-value is 0.333.
Yeah. 0.333. That's what I got.
Okay, so our p-value is 0.333, and our level of significance is 0.10. So I think that says we failed to reject the null.
Yeah. Oh, here we go.
Because later.
Okay, so 11 wants us to change the type of test from less than to not equal to.
Oh,
What is the correct decision based on this evidence?
we have. I think it would be we have insufficient evidence that the mean dentist bills between the two are the same. Oh, wait, no. Would that be right? We have insufficient evidence. But we have insufficient that they are different.
Okay. P is still larger than alpha, so we reject the null. So they're not equal to. So I would have picked we have insufficient evidence that the mean dentist bills between the two cities are the same. But I think maybe it's we have sufficient evidence that the mean dentist bills between the two cities are different.
I think
Well,
it would be
We're trying to prove that they are different. So if the argument is, are they not equal? The mean bill is not equal to, or so is not the same. Then, if you're trying to prove it, which we have a p-value of 6.6 or 6.7, then that's way too high, which means we don't have sufficient evidence. Because there's two ways to say it, whether it's either we have sufficient evidence that they are different or insufficient that they are the same. Wait, no.
vice versa.
Yeah, the other way around.
I think we have insufficient evidence that the mean dentist bills between the two cities are different.
Yeah.
But if we're rejecting the null, doesn't that say that they're not the same?
Yeah, the null hypothesis is always equal to. So we're trying to prove that it's
If
different.
we're rejecting the null, it means they're not equal.
So whenever I change the type of test is not equal to, my values didn't change.
Oh,
What did-
no. The null hypothesis is that they're equal.
Yes.
Yes.
So,
Wait a minute. We're failing to reject.
yeah.
Yes.
So we're accepting. Which I'm not supposed to say, but I have to say that I'm sorry, I'm dyslexic. Okay. So that we have insufficient evidence that the mean dentist bills between the two cities are different.
Let's see. Yeah,
That's
insufficient.
what I think.
Because it would be we have insufficient evidence that they're different. So, and that's the conclusion.
But real quick, whenever y'all change the type of test, what did your values change at all?
Yeah,
Or did-
yeah.
P-value did. I didn't look for
Or did-
anything else.
What did your t-value turn into?
0.6665435.
Okay, and what did you have before?
It was 0.3 something.
Okay. Because I have the 0.666. Maybe I just didn't notice that it changed. I was looking for all the others to change as well.
The t-value and the standard deviation doesn't change. I don't think the means or the other standard deviations, I don't think those change. I think it's just the p-value that changes.
Yeah, I think you're right. I just switched it back to less than, and I get 0.33 something.
That sounds right.
Okay. Cool.
Okay, so we want to clear contents before we change to the next one. Dentist office.
Right.
Freshman dinner.
Huh? Right.
Who wants to read next?
I'm gonna read next.
Okay.
It says you suspect that the freshmen from Utah cooked dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is mu1 equals mu2. Use a level of significance of 0.05. What is the appropriate alternative hypothesis? I would say not equal to.
Yeah. Yeah, it just says a different number, so as long as it's not equal, it's correct.
What is the test statistic?
We have to plug our numbers into the thing. Up at the top, I think it said mu sub 1 is Colorado and mu sub 2 is Utah.
I have a t-value of 0.845.
That's what I got.
Not there yet. You have a t-value of 0.845
Great. That's what I got.
or negative 0.845, excuse me.
I don't know.
I got
Is it negative?
negative.
I got positive.
You have to, because up at the top, it says U sub 1 is Colorado and U sub 2 is Utah. If you flip them, you'll get positive.
It'll be negative.
So Colorado
Okay.
goes in variable 1, Utah goes in variable 2, and then it'll be negative.
Let's see. Oh yeah,
Being tricky.
I saw that. But I assumed that they were in the right position. I didn't want to double check.
Yeah, me too.
That's why in I guess it was either 11 or 12, they were having that plus or minus business. Because depending on, even with the matched pairs, depending on how you put it in, will depend on whether you're going to get the positive or the negative. Which I found confusing because in the book, when we first started with the matched pairs, although these aren't matched anymore, but when we started with the matched pairs, it said to do, post minus pre, like x2 minus x1. But that's not always true, I guess. The p-value I got was 0.411 when rounded to 3 decimal places.
0.411.
Oh, and I did not change my confidence.
Wait a second.
0.95.
Value. I have 0.441. That would
If you got 411, that's what I got.
When I round to 3 decimal places, it's
0.411.
uh-huh. So P is obviously larger than alpha. Fail to reject the null hypothesis.
Okay, 18.
Concur.
Okay, so determine at a 95% confidence interval for U sub 1 minus U sub 2, and estimate for the difference between U sub 1 and U sub 2. Input your answers. Margin of error was more complicated. Does everybody have the formula?
18.
I do not. I'm pulling up the textbook chapter real quick.
It's not obvious in the textbook. Okay, P, this is going to be hard to explain. Actually, I'll just hold it up so you can see. This bottom one is the margin of error.
Oh my goodness. T times. Come on, could you hold it up one more time? Oh, I see. That's 1 squared. Square root of n
1.
plus All right.
That was part of that. If you click on the video for part 2, about 3 or 4 formulas show before you hit play. If you hit play, all of a sudden they're gone. And that one specifically said margin of error.
Okay. Let's give it a shot.
So T is -0.845 times S1 squared square root of
Okay. Right. The square root.
I come up with a margin of error of -8.3051. So -8.305.
Hold up. Let me. So close. S- 3 point.
I figure out how to do this myself.
Hmm?
I figure out how to do this myself. Right.
I had to completely take it apart.
Yeah, I'm just doing one little section at a time.
Mm-hmm.
Oh, wrong. Okay, my bad. All right. Okay, let me try that again. Weird. Divided by 12.
I got a very different answer. I'm gonna go back and check it. I got negative 0.2616.
Okay.
I got. Wait, did I just write? No, I didn't. Am I? Oops. 7.
I got minus 1.4672.
Oh.
So S1 and S2 are supposed to be raised to the second power.
Yes.
What, all of it was supposed to be squared? Is that why it was in parentheses?
The S1 is squared over the square root of N1, and then the S2 is squared over the square root of N2.
It's
All right.
So are we supposed to get the result of S1 over N1 plus S2 over N2? Then that is squared
No.
times
S1 is squared divided by the square root of N1. Plus, so like, when I took it apart in Excel, and I'm in the, oh, wait a minute, did I even square root the whole thing again? Hold on. Oh, crap, I think I did it wrong.
Oh. Oh, the difference.
Okay, left out the last square root. So I've got negative 2.649. Sorry.
Hold on, what was it again?
Negative 2.649.
I got negative 2.617.
Plus 9214.
So you got 614?
2.649.
Okay.
But I'm going to go because I completely left out that second square root over the whole right side. That was my bad.
Mine is off on just a little bit from yours, so it makes me think it was a rounding issue.
Yeah, I didn't let anything round until the end.
I think we should go for that answer.
So at first, I've got the negative 0.845 just on its own. And then my second step was, in parentheses, I multiplied 4.517 times itself, close the parentheses, divided by the square root of 10. Left that one by accident, because that's the S1 squared divided by the square root of N1. And then I did the same thing on another line for S2. So 3.420 times itself, close parentheses, divided by the square root of 12. Then left that one alone. And then I took those two lines and added them together. All the S1 stuff, all the S2 stuff, added them together. And then my last step was take negative 0.845 times the square root of what I just summed. And then I came up with negative 2.649.
All right, I just realized that I had the denominators switched.
Yeah, it's involved.
10 and 12.
Yeah. I'll go back and look, because on the dyslexic one I could have had that. No.
Yeah. All right, so it's S1 over N2.
S1 squared over
Yeah.
the square root of N1.
Yeah. I'm making things out of it.
And then I S2 squared over the square root of N2. And I did those separately, and then I added them together. Now, I think I can check my answer if,
Interval.
yeah, the interval is x bar sub 1 minus x bar sub 2 plus or minus what we, what's our margin of error. And that'll give us our confidence intervals. So 15.200 minus 16.667 plus or minus, if I get the confidence intervals.
Right.
Wouldn't it just be the values in the spreadsheet?
Which value?
For the confidence interval?
Yeah, we're supposed to get the same confidence intervals when we add or subtract from the add or subtract the margin of error from x bar sub 1 minus x bar sub 2.
15.2 minus.
So this is a way to double check our margin of error.
I think so. Oh, it's not working.
Oh. Five.
Mark, could you show your margin of error equation again? Okay. Just wanted to make sure. The first
And
time I
then whole confidently get back to the right spot. The okay, close enough.
okay.
So that half is the margin
Thanks.
of error, plus or minus that.
And it's not.
It's not working. Well, how did I work it backwards with the other one?
Oh. Zach.
So is the margin of error always negative, or is it just?
I don't think the margin of error should ever be negative because it's saying, what is it? Because it's like saying you have a sample mean of 37, plus or minus -3. Like, what does that mean?
Yeah.
It would essentially would mean the exact same thing. Just so if it's negative, it would just, it's wrong, but it means the same thing either way. But I don't think it ever should be negative either way.
Okay. Maybe that's our first clue. Because from my Excel calculations, we have a negative margin of error.
But the T is negative.
T.
And that's what we start with, T times.
Well, let's see. Well, the difference of the means is going to be negative anyway.
Yeah.
All right. Yeah. Which I don't think it really doesn't matter if it's negative or not. The confidence, the margin of error, because you go plus or minus anyway. So whether you got a margin of error of 2 or -2, it's not going. If you put it in the calculator, it's not going to make any difference. In the end, you're still going to have a higher and a lower interval of 2, +2, and -2. So I don't know if it, like I said, I don't know if it has to be always positive. I do know that it actually really wouldn't make a difference if you calculate it.
Okay, what upper bounds did y'all get using?
Oh.
On your last class?
Oh, let's see. Oh, hold up. I need to do something real quick. I can just do it all by hand. Okay. 1.969 minus.
We should be able to work backwards from the confidence level, and I can't remember how, or confidence intervals, and I can't remember how to do it.
Weird.
Oh.
What we did last time?
Yeah, well, we only had one standard deviation, and so I, the standard deviation plus whatever the margin of error is gives us the upper interval. The standard deviation minus whatever the margin of error is gives us the lower confidence interval. But this one's a little more complicated because you have to do the mean of maybe it's the standard deviation. Too many formulas running around in my brain. I don't know anymore. It's all gobbledygook.
So just to go back to the basics, P1 is Utah, or mu, Colorado.
Variable 1 was Colorado, and variable 2 was Utah.
Here we go.
We at least have the confidence intervals on the sheet. Negative 5.147 is
Does
the lower.
on the original data,
Yeah. Well, I looked through lots of the reading again, and the only thing I found was to compute the 95% interval. It says to do it in Excel, the confidence interval, which it says it's right here. So if that's 50% of whatever that number is our margin of error. And without any other provided formulas, that's the only thing I think that's the only thing I can go on, at least.
Yes. So what's 50% of the difference?
Oh. 74 plus 2. Uh, 3.681 rounded. Listen.
All right, it's better than nothing. Did I not answer 12? Oh, no, I just didn't hit save. All right. Do we want to just submit and see where we're at?
Yeah, sure. Let's see.
Yeah, I'm almost in.
And yes.
And we did it.
So it was 50%. It's 50% of the difference
Between the lower bound and the upper bound.
values. Of the top.
Yeah. I did it real quick by just inverting the lower bound if it's a negative. It's really easy if it's a negative. Otherwise, you have to do some fancy math. But yeah. So, yeah. All right. Well, I didn't feel particularly good about that, but they didn't, or at least in my scanning, I didn't notice any formulas they gave, at least in this lesson. So
The one I shared is on the very, very beginning of video 2.
yeah. Oh well. Well, I feel a little shaky on that still, but
Yeah.
I guess they told us to do Excel, so we did Excel and we got it right.
Yeah.
But hey, if it works,
If it ain't broke, don't fix it.
I just like to be able to do it by hand so I can, check it with the Excel rather than just use Excel only. But yeah. And there are formulas and they are out there. We just couldn't find them. Oh well.
All right. Thanks, guys.
Mm-hmm.
Stop broadcast. When do we want to meet next week since it's a unit test?
Oh.
We have a lesson the first half of the week, and then we have a unit test due by Saturday.
A lesson first half of the week. Oh, I already exited out of my stuff. When is the review? Is our first or second meeting next week going to be the unit review?
The second meeting would be the unit review.
Oh, then in that case, I don't see any reason to meet any differently. In fact, I'd rather us meet regular time on Monday. So if we needed to for the unit review, we can meet later for that.
I was going to say, could we meet Monday and Thursday?
Yeah, that sounds better.
Is that okay with everybody?
Yeah, that way we can get
that's fine.
we can get the regular lesson out of the way, and then we have Tuesday, Wednesday, and Thursday to do the unit review. Get ready for it at least.
Okay, and I'm starting to get, there's too many numbers. 3 o'clock Mountain Time or 4 o'clock Mountain Time?
Oh, for Monday?
For both days.
Oh.
Work best for me.
That's for me.
Is that 3 o'clock Mountain Time?
Yeah.
Yeah, 3.
Okay. 3 o'clock Mountain Time for both days.
Mm-hmm.
Okay.
Monday and Tuesday. Or Monday and Thursday.
I'm gonna have to look at my flight schedule. I hope it's late enough. I may or may not be with you on Thursday.
We'll see. If we need to, we can just meet on Wednesday, or if that's not even possible, then we'll see what we can do. Don't worry about it.
Yeah, my problem is I may be traveling both Wednesday and Thursday. I'm hoping it's Tuesday and Thursday, but we'll see.
All right.
We're getting ready to head to Washington State for the summer.
That's cool.
It is.
Whoa.
I'll be living with my dad, who's my tutor, and so we'll just get up in the morning and we won't have to FaceTime.
Hee.
Okay, so the point is Monday, 3 p.m. Mountain Time. See you guys then.
All right. See you guys. Good luck.